just cover a couple of things. I was asked yesterday to do this, and it probably is something that needs to be repeated, we need to be reminded of, and that is what makes Citri-Fi different than other fibers. And when I give a presentation to customers and so forth, I point this out right from the very beginning, that our fiber is different than other fibers for basically two reasons. One is that where other companies that make fibers grind the particle size smaller and smaller in order to increase the surface area. Because when you cut the diameter in half, you increase the surface area 4 times. And we don't do it that way to start with. What we do is we have a patented process that mechanically opens up that fiber structure. And so we get about a 20 times increase in surface area, but much of which is on the inside of the fiber particle, not strictly on the outside. And so where other people rely on hydrogen bonding on the outside of small, like wheat fiber or bamboo fiber particles, it's a weak bond that's easily broken during baking or cooking or freezing. That's why you'll see other fibers that are used in products that are frozen where the water breaks loose and moves to the surface of the bread or the meat product and forms those ice crystals on the outside. And when our fiber is used in those types of applications, we're able to bind and hold that water inside of the baked good or meat product, and far less of that water migrates to the surface. And that's one of the things that's different. The second thing is that other people tend to purify their fiber. They try to increase the insoluble fiber content and get rid of everything else, or they try to increase the soluble fiber content. And we don't do that. If you take a chemical composition of our product, either before this process or after it, you'll find that the chemical composition is almost identical. And if you note on the chemical composition, we've got about half insoluble fiber and half soluble, about 70% total, whereas other wheat fiber might be closer to 80 to 90% dietary fiber. We're less than that. One of the things that makes our product different is the protein content. You'll note that it's about 8%. And that's where we have the lipophilic attraction between the protein and the oil. And this is one of the reasons why in many applications we suggest that the fiber be predispersed in the oil first, so that the oil comes in contact with that protein. And then when the water is added and the fiber starts opening up, it will pull both water and oil into that fiber matrix. And so that's where we get the emulsification or stable, the ability to stabilize emulsions because of that protein in there. Now if you hydrate it with water, you will have far less ability to have an emulsification effect unless you put it under high shear with the oil. Otherwise, all your bonding points are basically covered with water, and the oil is going to have a difficult time interacting with the protein. And so this, when you look back at this, then where other fibers have basically the hydrogen bonding on the outside of the particle, we have not only the hydrogen bonding with the soluble fiber, the insoluble fiber, but we have the lipophilic attraction between the protein and the oil. When we pull that into the fiber structure, we have the insoluble fiber putting surface tension on the water and the oil to hold it. So we've got multiple things going on there. And then with the 200 material, when we infuse the guar gum into that fiber structure, that's why we get that synergistic effect, or the ability to bind 30% more water because of getting the guar inside of that fiber structure and pulling. So that's what makes our fiber different, and why we're able to bind and hold more water through a cooking, baking, or freezing process. And it's real important, I think, to explain that to customers so they understand why it is different. And then, of course, everybody has their own number on water holding capacity, and we hear numbers as high as 18 times or 25 times. But we use a standardized method, the AACC 5630 method, and which creates a level playing field when you compare fibers. But the thing that I point out to a customer is what a fiber holds in a centrifuge doesn't make a speck of difference in terms of how much money they can make. It's where they can make the money, and what's really important is how much water can it hold through a baking process, after it's baked, after it's cooked, after it's put in the freezer. And this shows how in 60 minutes, after hydrating the same amount, 5%, this gel, scratch the gel, it's really not a gel, but it shows after mixing the wheat fiber, the soy fiber, the Citri-Fi, and then within an hour, how it's settled out. And then I just wanted to touch on this because I think that this is an area that is easily missed. It's easily misunderstood. I think that there is a huge, huge opportunity to put 0.25% to 0.5% of Citri-Fi on top of whatever other fiber people have chosen to use in their products. And I find that many of our distributors try to get a customer to change from wheat fiber to Citri-Fi or change from bamboo fiber, and then they run into the cost issue and all of the objections. And I wouldn't go there. If you've got 100 customers that are using 100 different fibers, I wouldn't try to change one of them to Citri-Fi. I would try to get them to try 0.5% or 0.25% of Citri-Fi on top of what they're already using. And because I think that they can increase their profitability, can increase the water binding, and I just want to show this graph, and it's in our user guide, compares wheat fiber, the 200 and the 600, to Citri-Fi. And it goes across from the left to the right, showing the yield increase in blue compared to the control or the reference, which is over on the right-hand side. The green shows the increase in profit compared to the reference. And then the red shows the lost profit as compared to the best one, which is the Citri-Fi 1%, 100, over on the left-hand side. So wherever it shows red is a lost profit compared to Citri-Fi. So when you go to wheat, a 2% wheat 200, there's a 1.8% loss of profit that we think we can help that manufacturer gain back. And this also is in the user guide. It compares if we just add 0.5% on top of bamboo, soy, wheat, carrot, or soy protein. The purple shows the extra profit that we can deliver to the customer. So you see with the wheat fiber 200, if we add that 0.5%, we gain 0.9% of extra profit. The previous one, they were losing 1.8. We're able to gain back half of that loss. And if this is in meatballs, cooked meatballs, so it's after cooking. And so if someone is earning 10% of sales as net profit, and they can go to 10.9%, that's a 9% increase in their net profit from using just 0.5% of Citri-Fi on top. So if there's 100 customers out there that are using some other fibers, I think I would, after a year, I think I could convince maybe a third of those people to try Citri-Fi at 0.25% or 0.5% on top of what they're already doing. And I would much rather have 33 customers using a little bit of Citri-Fi than I would have 5 customers using 100% of Citri-Fi. Because once they start using it and have it, start learning how it can be used, they'll figure out other ways to use Citri-Fi. So this is, I think, a huge opportunity for us. When you think of all the customers that are already using other fibers, I wouldn't try to change them, but just show them how they can add 0.25% or 0.5% of Citri-Fi on top and see if they can increase their yield, make their product more palatable, more moist, that type of thing. All right, Brock, you got, is Brock Dennis?